Okay, hello everyone. We seem to have had a little bit of a snafu. So, in the famous words of a TV host, we're gonna do it live. All right, here we go. Hello everyone. My name is Peter Kacandes. I am a senior technical product marketing lead at Imply.io, and today we're going to be talking about putting big data, self-service analytics into the hands of business people and what that really means in today's world. So the agenda that we're going to be following today is to discuss what we mean when we talk about, what is often called sort of temperature-tiered analytics, and what that is in the context of the types of decisions and workflows that need to be made by business people, and the trends that are driving how that's been evolving. Then we're going to cover how real-time data platforms fit into those scenarios and how it supports solutions for them to cover some important benchmarks. Then we'll wrap up by covering how this is differentiated from today's typical cloud data warehouses. So what is hot analytics? We talk about them as hot analytics are fast, fresh, and for everybody. What we mean by fast is that they have sub-second query response times. By fresh, we mean that they can leverage all of the deluge of data that's pouring into the enterprise in real time. But that being said, that there are also situations where you may want to be able to do, fast queries on top of the ingestion of non-real-time batch data too. So ideally, it's important that you're able to support both of those use cases. Of course, it's probably most interesting and productive for the enterprise when you're doing both fast and fresh. Regardless, fast is really the key word there, because you don't want the productivity of your business people affected by them having to wait for slow queries to execute, particularly when they're doing ad hoc discovery and analysis. When we say for everybody, that means that they can be accessed and used by actual frontline business people and decision makers, and aren't limited to specialized data scientists or analysts who then present that information to the decision makers. This is really the concept of self-service, where the data is available for exploration in a way that's intuitive for the subject matter experts in the business to work with it directly themselves. So you're breaking that chain of sort of the traditional analytics model, where the business person has to describe what they want the analyst to do, who then has to go off and figure out how to get the right data and then write up some queries or produce a report or some dashboards, give it back to the business person, who inevitably is then, it's not quite what they wanted. And so you wind up going through a whole nother cycle of that. And by the time you get through it, it's probably too late to take action, or the impact of having taken that action is greatly reduced because of that time delay. And we'll get into some specific examples of that later on. All right, so when we look at these three tiers, I think the important thing to understand is that not all workloads are created equal. So let's talk about the temperature gradient concept. And that concept, when we think about it, is really sort of what's driving how we're building data architectures around that. I'm going to speak to this from left to right. So cold is the farthest to the left. The idea behind cold data is that everything is available. It's kind of like your default. You can think of cold data as the stuff that you're storing in HDFS or S3 or cloud storage, or wherever your data lake is, for example. That's your cold data. It's very low cost. You're basically most of the time paying only for the cost of storage. So whether you're using Hadoop or Spark or S3 or whatnot, you're generally just paying the cost of storage, and you're getting whatever compute instance comes along with that for free, or maybe you're getting some temporary compute capacity to go along with it. But it's not performance sensitive. These are the workloads where you just want to dump everything in. You may not be entirely sure what exactly it is you're going to do with it. You may want to do a wide variety of things. What's most important is that you're price sensitive rather than your performance sensitivity. So that's kind of emblematic of cold data. That's your default. Some data sets are going to be a little bit warmer, where most of the data is available, but not all the data. In this situation, the cost is going to be moderate, as is the performance. This is essentially your balance system, where you're not necessarily striving for true real-time performance. You have a little bit more specific idea of what you want to do with it, and you also have a more definitive idea of what the value of that data is. As a result, you're able to justify paying a bit more for it. Additionally, you might also be dedicating some compute resources. And then from there, we sort of step up to hot data. Hot data is, these are critical data sets, and you're likely not to, have all of your data in your hot data sets at your fingertips for cost reasons. But these are the business critical data sets, and they'll have a greater propensity to always be online. And you are pretty likely to have dedicated compute resources available to it. Perhaps most critically, the latency of the data is extremely important. So this is the spectrum, and different systems do well at different places on the spectrum, and we'll get into that. This is just contextually one way to think about that. Another thing to consider is that at different times, there can be good reasons to move data to different places on the spectrum. The data set itself, may not be inherently cold or warm or hot, but its place on the spectrum is an artifact of what it is that you're going to do with it. So as you have new data sets, and as you learn more ways to get value of it, and as you learn that there can be more teams within your organization that can make use of it, you may take it out of a system that's designed for cold access and put it into a system that's more suited to warm or hot access. It can also be very productive for the organization, to have systems available that can handle these different temperatures of data and to be able to move between them. All right, so let's dig in a little bit deeper specifically on hot analytics and why that's so increasingly important for businesses, especially, in these kinds of volatile and unpredictable times that, we've been experiencing of late. There are two major categories of workflows involving hot data across, all kinds of different vertical industries, and those are monitoring and exploration. These use cases tend to be the ones where you get the most value out of real-time data. Monitoring trends to be, dashboard driven with the ability to drill down for further levels of detail and analysis. Exploration tends to be more driven by the need to have interactive tools for ad hoc exploration and discovery to gain critical insights into the data. In the case of Imply, we've made a user interface for Druid called Imply Pivot. On the right-hand side of the slide, you can see an animation for exploration, because it can be a little bit difficult sometimes to explain the story and the idea behind a UI like Pivot without using some video or animation, because the whole point of it is to be interactive and exploratory. So the idea is that you're using the ability of the system to see fresh data for monitoring, but then you're taking advantage of the system to be able to do very fast sub-second queries, both on historical and real-time data, getting things like comparison there to be able to do ad hoc exploration via the drag and drop of parameters. So UI-wise, these are the kinds of workflows you can expect with hot analytics on a hot data set. So where are hot analytics required? In terms of use case areas where we see a lot of enterprises are increasingly taking advantage of hot analytics, you can see a number of ones here that have proven to be particularly suited for it. I'm going to talk just about a couple of them quickly. I'm not going to go into all of them. With clickstreams, you're probably pretty familiar with it. Where enterprises increasingly have their customers who are consuming their products or interacting with the company through a variety of applications, both web and mobile, and other digital channels like SMS, push notifications, and even email. There are a couple of trends that are driving this. On the whole issue of digital transformation that's been top of mind for a lot of senior leadership for a couple of years now, while they're pushing all aspects of their organization to expose their functionality to their stakeholders via digital applications for fear of being disrupted by digital natives. Similarly, if you look at reports like Mary Meeker's annual Internet Trends Report and just your own experience from your own lives, especially these days, you can also see the amount of time that consumers are spending with applications, and the consumption of media continues to increase. And yeah, that's all been exacerbated, even more so with people spending a lot of time, at home and not being able to go out and engage, with the traditional physical entities, who on their part have also been scrambling to make their products and services, more accessible and available to people through applications, because they can't even come into those physical spaces anymore. So with Clickstream, you're looking at what users are doing on that website or mobile application. Both of those capabilities, both fast and fresh, matter a lot for Clickstreams. The fastability, the ability to have data being loaded in real time matters when you're looking at something that's happening today or even right now. Just a few quick examples of that could happen. For example, if you're a product manager and you're rolling out a new feature and a new version of the app that you've just pushed out to the App Store, and you want to understand, are people using it? Does it work? Is it throwing errors? Is it increasing or perhaps, heaven forbid, even decreasing engagement? Similarly, if you're doing A/B tests and you want to measure the A/B test, whenever you're doing analyses that require looking at what's happening today, which do frequently come up in clickstreams, that fresh aspect matters a great deal. The fast aspect matters a lot too for historical queries where you're looking out over a longer time, a period of a week to a month or more for things like, retention or churn analysis, maybe estimating the size of your audience, understanding the use of features over time, and the behavior of your user base over time, and how the user base evolves over time. Like, is it growing or hopefully not shrinking? Is it changing in some ways? Are you getting your users from different sources and more things like that? Those are all examples of historical analysis that don't necessarily need real-time data, but they do need the ability to be able to do fast queries over a very large data set. And because you can have this very iterative exploratory workflow as you're investigating and looking to derive insights to try and understand what's going on, not just with the app, but especially with how that impacts your business, the key performance indicators by which you're judging your progress. Now, if we take a look at the use case for metrics and APM, Druid is an interesting database in that it's not conceived of as a time series database, but it's actually pretty good for time series data. And that's because it turns out Druid is a relatively general purpose analytical database that can work quite well for time series data. And with a lot of the more specialized, dedicated series databases, what you're seeing is that they are evolving under the hood to look less like a classic TSDB, and they are actually kind of becoming more general purpose because of the types of analyses that people want to do on them. And so what we're seeing is a lot of people are increasingly using Druid for metrics and APM. If you have those types of concerns where freshness matters, of course, for metrics and APM, perhaps the most for anything, because you want to have observability into what's happening with your apps and your networks and your systems from a technical perspective, like right now. And similarly, because they're producing massive amounts of telemetry, you also need to be able to do fast queries on both the real-time and historical data. And another interesting thing about that is that the observability of what's happening right now might not actually tell you much without the ability to see it in the context of what has happened historically and how it's different or similar to know what's even normal or not. You might have a certain level of CPU usage or network connections being made. When you're doing diagnostics or troubleshooting type workflows, that ability to really be able to pivot through your data is pretty super important. So yeah, like I said, I'm not going to go into all of these individually in the interest of time, but hopefully you can get back from those two examples of hot data and the freshness of it and the fastness of it. And why you need that need for fast queries and the ability to also do, historical companions to, see how it applies to those other use cases and in a variety of different situations. All right, so, with all of that said as a preface, let's dive into why existing data warehouse-oriented architectures are not really positioned or even adequate in many cases and can struggle to support these requirements. It's a little bit hard to make generalizations in the market because to a degree you can think of Druid as a data warehouse. So it's not like these systems can't do anything, but what we're really talking about are the classic data warehouses, the ones that are quite prevalent and popular, and some of which have had even pretty big public events recently. The first thing is that many of those established cloud data warehouses orient their ingestion around batches. Some of them can even do like micro batches, maybe even a batch every minute, or maybe even every few seconds. But it's quite rare that they're doing true streaming. While a few may have true streaming, it's not a common feature, and that limits your ability to build like a really streaming data pipeline. Whereas, with something like Druid, if you hook up with something like Kafka, you are going to get true streaming where you have data coming in with end-to-end latency on the order of a couple of milliseconds. On the compute side with common popular data warehouse architectures, they really tend to focus mostly on this cold and warm temperature of data. They tend to either not have any dedicated resources, or they tend to have a little bit of dedicated compute but no dedicated storage or no co-location. And it's this lack of dedicated resources, and depending upon they store the data or not, the result can be that your typical business queries that take many seconds and in a surprising number of cases even many minutes to execute. Even with relatively simple queries, they can take that long, which might not seem like a lot, but when you have high query volumes across large user base, it really starts to add up, and it can bog down pretty quickly. Next, looking at usage, the result of these two things is that you aren't getting queries that are incredibly fast. You aren't getting ingestion that is credibly real time. So from the usage side, they are very much focused on and build towards things like static reports and classic analytics tools. So what do you need to do to add hot analytics to your systems? Let's take a look at what do we mean by hot stuff and how do we add hot analytics capability to our business. And it's something that goes across the entire stack. In the center of it on the compute side is a real-time analytics database like Druid or something like Druid. On the ingestion side or data integration side, you want the ability to do true streaming instead of batches or even micro batches. Of course, in Druid you can do both. But for a lot of organizations, they prefer to build new data pipelines for new capabilities and better performance before changing over existing pipelines that they already have in place. On the visualization front, you need a system that enables self-service exploration. The reason for that is that the whole point and the value of hot analytics is that people can do these modern exploration workflows, as we described earlier, on these business critical data sets. So you need to give them the tools that enable them to do those types of self-service and ad hoc exploration. And the motivation for this is really coming from the executive leadership perspective, is that they want to reduce cycle times, get the business moving faster, be more responsive to dynamic and changing business environments and customer needs. And the way to do that is to push decision making down to the frontline business folks who have that domain expertise. But in order to react quickly enough, they can't be waiting around forever for their queries to complete every time they want to make a modification, or for them to be reliant on specialized data analysts to take their requirements and come up with the data, because that's just a serious bottleneck. That makes cycle times can be days or even weeks or even months. Even at an organization, I used to work at AWS, where I was doing product marketing for the mobile services, and we had a traditional Oracle data warehouse. We had incredibly sophisticated marketing analytics, but the mobile services were a little bit distinct from a lot of the other services, and so I needed different kinds of reports. But because mobile services, what's that? Oh boy, we got a lot to get through. Okay. So these are some of the characteristics of data platform. Not really going to go through those in detail right now because I have 1 minute left. If you go to Druid, it's high performance, real time analytics and database. These are some of the features that help it do all those things. So you're not convinced. This is the big takeaway here. We ran a query versus, we ran a performance benchmark using the star query benchmark. And, basically, you can see there's some variability there, but in essence, we're up to 3x faster. And, if you look at the performance advantage, it's anywhere from, on average, it's about 12x, but, it can be, greatly more than that. And just to give you a sneak peek, we did the same benchmark from against Snowflake recently. So for those of you here, we haven't published that one yet. The BigQuery one you can get on our website. But we're 2.55 times faster than Snowflake, and anywhere from 7 to 24 times more cost efficient. So why is that? Again, we're running out of time here, but these are some of the areas when you compare Druid to cloud data warehouses that are implemented in Druid that are why the CDWs run a lot more slowly. And our customers are finding all kinds of really interesting use cases and ways to take advantage of Druid and real-time data analytics combined with historical capabilities that might involve batch data. Like just as we did a recent customer story on our blog with Ibotta for how they're using us for fraud detection. We did another one recently you can see on our blog with Dream 11, which is India's biggest fantasy sports league. And so we have some ones coming up with a very large network communications organization, telecom company. So stay tuned to look for that.